When you see a praying mantis, what do you think of? Probably something calm, right? Almost spiritual, just hanging out in the garden. Well, what if I told you that that whole serene posture is hiding one of the most precise, most ancient killing machines on the entire planet? Today, we're going to peel back that peaceful facade and get into the shocking reality of the praying mantis.
So which is it? Are we looking at some kind of divine messenger, a prophet, like its name suggests, or is it something way more calculating? That's the big question we're going to unravel right now. And trust me, the answer is a total masterclass in evolutionary deception.
And that deception? It all starts with the name. The very thing that makes it look so peaceful, that classic praying pose, is actually its biggest lie. Okay, so the word mantis literally comes from the Greek for prophet or seer. You can see why ancient cultures thought it was mystical. But here's the reality check. That pose isn't about prayer. It's a loaded weapon. Those front legs are what we call raptorial limbs, and they are lined with spines that just snap shut, like a biological bear trap. Ouch.
So how exactly does this weapon even work? Let's dive in and break down the biological toolkit that makes the mantis such a ruthlessly efficient hunter.
This thing is equipped with some seriously incredible hardware. For starters, it's the only insect we know of that has stereoscopic 3D vision. Yeah, just like us. But here's the catch. It doesn't see sharp details, it sees motion. Then you've got that famous, kind of creepy, alien-like ability to turn its head almost all the way around, and a strike so fast you literally can't see it happen.
And that head-turning trick? That's a huge advantage. Think about it. It can track prey from pretty much any angle without moving its body even an inch. That means it stays perfectly hidden, perfectly camouflaged, and its target has absolutely no idea what's coming.
And when it finally does move, it is explosive. We're talking a strike in under 70 milliseconds. I mean, to put that into perspective for you, that is about 6 times faster than you can blink your eye. By the time the prey's brain even registers a threat, it's already over.
This is just brilliant. It shows you how seriously scientists take this little insect. So to figure out its unique 3D vision, which, remember, relies on motion, not still images, researchers actually put tiny custom-made 3D glasses on them. Yes, you heard that right. Little insect-sized 3D movie glasses. All for science. Incredible. But look, the mantis isn't just about its physical gear. Its real genius? That lies in its strategy. And it all starts with this almost supernatural ability to just vanish.
I mean, some mantis species take camouflage to a whole new level. It's unbelievable. They don't just blend in, they become the environment. Take the orchid mantis. It's not hiding on a flower, it is the flower. Then you have the dead leaf mantis, which perfectly mimics a decaying leaf on the forest floor. And the twig mantis? Good luck spotting that thing on a branch. It's a level of deception that is just, wow.
And the orchid mantis, it takes this a step further. This isn't just hiding, this is active deception. It doesn't sit on a flower, it becomes the flower. And get this, studies show it can actually look more attractive to pollinating insects than the real flowers nearby. So it lures its victims in with this false promise of nectar, and then, bam, fatal strike.
All right, let's talk about the legend. The one thing that made the praying mantis so infamous. Its absolutely brutal mating habits. But is the story we've all heard the whole truth?
The official term is sexual cannibalism. It's exactly what it sounds like. The female eats the male either during or after mating. I know, it sounds totally monstrous, and it's pretty much cemented the mantis's reputation as a cold-blooded killer.
But here's the thing. It doesn't happen every time. Not even close. It's way more common in stressful lab environments than it is out in the wild. And now for the truly bizarre part, the male can keep, mating, even after his head has been bitten off. See, the controls for all that are in his abdomen, not his brain. In a really strange twist, losing his head can sometimes make the whole process even more intense.
So after that, let's call it a dramatic romance, the female lays her eggs in this really remarkable structure called an ootheca. It's basically a foam case that hardens into a protective little fortress, keeping the next generation of predators safe from the weather and other hungry insects. You know, this creature is so much more than just a garden predator. It's an evolutionary masterpiece. It's inspired humanity for centuries, and believe it or not, it's still shaping our future.
Just think about the timescale for a second.
The first mantis ancestors were out there perfecting their ambush tactics 135 million years ago. They literally watched the dinosaurs come and go. They inspired some of the very first martial arts styles in ancient China. And today, they're a model for some of our most advanced technology.
So, why does any of this matter now? Well, because engineers are studying the mantis's biomechanics, that crazy fast spring and latch strike, to build better, faster robots. AI developers are looking at its unique 3D motion vision to help create machines that can perceive depth and movement more efficiently. This ancient killer might just hold the keys to the next generation of AI and robotics.
And that really brings us right back to where we started, doesn't it? The praying mantis teaches us one simple thing. Looks can be so deceiving. It stands perfectly still, looking like the picture of calm and patience. But now we know the truth. Beneath all that serenity lies a predator honed by 135 million years of evolution.
So the next time you're in your garden and you spot one, just standing there, motionless, maybe even looking right at you, you gotta wonder, right? Is it just watching you, or is that tiny, ancient brain doing exactly what it was designed to do, calculating the distance?